This code installs the package called Finance by using the pip installer. The Q flag is used to suppress any output messages during the installation process. Finance is a Python library that provides a convenient way to access financial data from Yahoo Finance. By installing this package, the user will be able to retrieve and analyze various types of financial information, such as stock quotes, historical prices, and other related data directly from the Yahoo Finance website. This code imports the necessary libraries such as pandas, NumPy, Matplotlib, and Seaborn for data manipulation, visualization, and analysis. It also imports additional libraries for reading stock data from Yahoo Finance and for working with timestamps. The code then defines a list of tech stocks, sets up the start and end times for data retrieval, and uses a for loop to download the stock data for each stock in the tech_list. Next, it creates two separate lists, company_list and company_name, which correspond to the downloaded stock data and the respective company names. This loop then adds a new column called company_name to each stock's data, assigning it the corresponding company name. Finally, the code concatenates all the stock data into a single data frame, DF, and displays the last 10 rows of the data frame. The code calculates and provides summary statistics for a dataset related to the stock prices of a company, specifically Apple Incorporated. The dataset is likely to contain various variables such as opening and closing prices, high and low prices, trading volume, etc. By calling the describe function on the Apple dataset, the code generates a summary of these statistics. The summary includes measures such as count, mean, standard deviation, minimum, 25th percentile, first quartile, median, 50th percentile, 75th percentile, third quartile, and maximum values for each variable. Additionally, it may also provide information on the data types present in the dataset. This summary helps in gaining a quick understanding of the dataset's distribution, central tendency, and overall range of values. It can be useful for identifying outliers, assessing data quality, and initial exploratory data analysis. The code apple.info retrieves general information about the stock symbol Apple, which represents Apple Incorporated. This method provides an overview of the company's stock, including details such as the company name, sector, industry, exchange it is listed on, market capitalization, number of outstanding shares, and other key metrics. By calling the info function on the Apple stock object, it enables users to quickly access and display essential information related to Apple's stock. This can be useful for investors or individuals interested in tracking or analyzing Apple's financial performance, market position, and other relevant details without the need to manually gather or search for this data. This code generates a historical view of the closing prices for multiple companies. First, it creates a figure with a size of 15 by 10 units. The top and bottom margins are adjusted to ensure the plot is properly displayed within the figure. Then, it uses a for loop to iterate over each company in a list called company_list. Inside the loop, it creates a subplot in a 2 by 2 grid, and selects the appropriate subplot based on the current iteration count. Next, it plots the adjective close values from the company's data using a line plot. The y-axis label is set as adjective close, and the x-axis label is left empty. The title of the subplot is set to the company name derived from tech_list. Finally, it ensures that the subplots are properly spaced and displayed using plt.tight_layout. This code is plotting the total volume of stock being traded each day for a list of companies. The code starts by creating a figure with a specified size and adjusting the subplots to have proper spacing. It then proceeds to iterate over each company in a given company list. For each company, the code creates a subplot in a 2 by 2 grid, with the current company's index as the position of the subplot. It plots the volume data for that company, with the y-axis labeled as volume and the x-axis having no label. The title of the subplot is set to indicate the sales volume for the corresponding company. Finally, the code ensures tight layout for the subplots, ensuring that they are properly spaced and displayed within the figure. This code calculates and plots moving averages for different companies' stock prices. In the first part of the code, A list called ma_day is defined with various values representing the number of days over which the moving averages should be calculated. Then, for each value in ma_day, a nested loop iterates over each company in the company_list. Within this loop, a column name is created based on the number of days in the moving average. The company's stock price data is then used to calculate the moving average using the rolling method, and the result is assigned to the newly created column in the company's data. In the second part of the code, a figure with 2 rows and 2 columns is created to accommodate the plots for each company. The size of the figure is also set. Then, using the plots created, the code selects specific columns from the company's data, including the adjusted close price and the moving averages for different days, and plots them on the corresponding axes. Each subplot is given a title based on the company it represents. Finally, the figure is adjusted for tight layout to ensure readability. In summary, this code calculates moving averages for different companies and plots them in a grid layout for visualization. The given code calculates the daily return percentage for each company in the company list. It does this by using the pct_change function on the adjective close column of each company's data. Then, the code plots the daily return percentage for each company on a 2x2 grid of subplots. The figure size is set to 10 units in height and 15 units in width. For each company, a subplot is created and the daily return percentage is plotted using the plot function. The subplot title is set to the name of the company. Finally, the code adjusts the layout of the subplots to ensure they fit nicely within the figure. This code generates a figure with multiple subplots using the matplotlib library. The figure has a size of 12 by 9 inches. Inside a loop, the code iterates over a list of companies and assigns an index value to each company. With each iteration, a subplot is created in a 2x2 grid, with the position of the subplot determined by the index value of the current company. Inside each subplot, the code plots a histogram of the daily returns of the corresponding company. The number of bins in the histogram is set to 50. The x-axis of the plot is labeled as daily return and the y-axis is labeled as counts. The title of each subplot is set using the name of the company. Finally, the function tight_layout is called to ensure that the subplots are properly arranged within the figure, avoiding any overlap or overcrowding. This code performs a series of actions to gather and analyze financial data for a list of tech stocks. Firstly, the code retrieves the closing prices for the specified tech stocks from a data source using the Pandas data reader module. It stores the data in a data frame named closing_df, specifically selecting the adjective close column. Next, a new data frame named tech_rets is created to calculate the percentage change in the closing prices over time using the pct_change function. This provides a measure of the returns for each tech stock. Finally, the code displays the first few rows of the tech_rets data frame to provide a summary of the calculated returns. This code uses the Seaborn library in Python to create a scatter plot showing the relationship between the Goog stock prices on the x-axis and the Goog stock prices on the y-axis. The dataset used for plotting is called tech_rets. The purpose of this plot is to compare Google's stock prices to itself, which should show a perfectly linear relationship because it is comparing the same stock. The scatter plot is used to visually observe any patterns or trends in the data. The color of the plot points is set to sea green for aesthetic purposes. By comparing Goog to itself and visualizing the data in a scatter plot, any deviations from a perfectly linear relationship can be easily identified and analyzed. The code uses the joint plot function from the Seaborn library to create a visual comparison of the daily returns of Google and Microsoft. The X parameter is set to Goog, which represents the daily returns of Google, while the Y parameter is set to MSFT, which represents the daily returns of Microsoft. The data parameter is set to tech_rets, which is the dataset that contains the daily returns of both Google and Microsoft. The kind parameter is set to scatter, indicating that a scatter plot will be used to display the data. The resulting plot will show the relationship and distribution of the daily returns of Google and Microsoft, providing insights into their performance and potential correlations. The code provided is using the pair plot function from the Seaborn library to generate a visual analysis of comparisons. The data frame, tech_rets, is passed as a parameter to the pair plot function. The pair plot function allows for the automatic generation of plots that display the relationship between different variables in the data frame. By specifying kind=reg as another parameter, the code is requesting the pair plot function to draw regression lines on the scatter plots, which helps estimate and visualize the linear relationship between variables. In summary, this code is essentially producing a comprehensive visual analysis of comparisons between different variables in the tech_rets data frame, including scatter plots with regression lines. This code sets up a figure called returns_fig and applies a paragrid function on a data frame called tech_rets. The paragrid function divides the figure into a grid of subplots, each corresponding to a pair of columns in the data frame. In the code, the upper triangle of the grid is customized using the map_upper function. In this case, scatter plots with purple markers are plotted on the upper triangle. The lower triangle is customized using the map_lower function. Here, kernel density plots, KD plot, are plotted with a cool color map, cool_D. Lastly, The diagonal of the grid is customized using the map_diag function, which plots histogram plots, hist, of the daily return with 30 bins. This code sets up a figure named returns_fig and uses the Seaborn library to create a pair plot. The pair plot is a grid of scatter plots that visualize the relationships between pairs of variables in the data frame _df. The upper triangle of the pair plot is customized to use the scatter plot type with purple color. The lower triangle is customized to use a kernel density estimate (KDE) plot type with a blue-purple color map. The diagonal of the pair plot is customized to show a series of histogram plots depicting the daily returns, with 30 bins. Overall, this code creates a visually informative representation of the relationships and distributions of variables in the _df data frame. This code creates a visualization of correlation matrices for two sets of data. The code sets the figure size to be 12 inches by 10 inches. It then creates a subplot with a layout of 2 rows and 2 columns and selects the first subplot. In this subplot, the code uses the Seaborn library to create a heat map of the correlation coefficients of the tech_rets dataset. The heat map includes annotations displaying the correlation values and uses a color map called summer. The title of this subplot is set to correlation of stock return. The code then moves to the second subplot in the same layout. Similar to the previous subplot, it creates a heat map using the Seaborn library, but this time for the correlation coefficients of the _df dataset. Again, the annotations are included and the summer color map is used. The title of this subplot is set to correlation of stock closing price. This code performs the following tasks. 1. It drops any rows with missing values, nan, from the tech_rets dataset and assigns the resulting dataset to a variable called rets. 2. It calculates the area of circles to be plotted using the formula pi multiplied by 20, and assigns it to a variable called area. 3. It creates a figure with a size of 10 inches in width and 8 inches in height, using the plt.figure function from the matplotlib library. 4. It plots a scatter plot using the mean and standard deviation of the rets dataset as the x and y coordinates, respectively. The size of the circles is determined by the area variable. The labels for the x and y axes are set to expected return and risk, respectively. 5. It iterates over the columns of the rets dataset and adds an annotation, label, for each column at the corresponding mean and standard deviation coordinate point on the scatter plot. The annotations are positioned using an offset of 50 points from the coordinate point, and they are placed in the bottom right corner of the annotation text box. An arrow is also drawn from the annotation text box to the coordinate point using a blue color and an arc3, rad equals 0.3 connection style. This code fetches the stock quote data for Apple Incorporated, AAPL, from the Yahoo Finance API. It specifies a start date of January 1, 2012, and an end date of the current date and time. The fetch data is then stored in a pandas data frame object named df. Finally, the df object is displayed, showing the stock quote data for Apple within the specified time range. This code initializes a figure with dimensions of 16 by 6 inches for plotting a line graph. It sets the title of the graph as close price history and plots the close column from a data frame on the y-axis against the index of the data frame on the x-axis. The x-axis is labeled as date with a font size of 18, and the y-axis is labeled as close price USD, dollar, also with a font size of 18. Finally, it displays the plot. This code snippet creates a new data frame by filtering the close column from an existing data frame named df. The close column likely contains closing prices of a stock or some other financial instrument. The next line converts this data frame into a NumPy array, which is a multidimensional array used in numerical computing. This NumPy array, named dataset, will now contain the values from the close column. The final line calculates the length of the training data that will be used to train a machine learning model. It does this by multiplying the length of the dataset by 0.95, 95% of the data, and then rounds it up to the nearest whole number using np.ceil function.